to innovate the ARM Neoverse advantage. Ladies and gentlemen, please welcome Mr. Awad.
Tripped on that, getting ready to go do this earlier today too. So, thank you, Dr. Sun, for the introduction. Thank you all for being here. It's really great to be here in Taiwan, and you know, they told me I had to start off with a video, so I'm going to start off with this.
The world runs on ARM, where a tiny thing means everything. From town square to Times Square, ARM is defining the future of computing. A future built by one of the most successful technology ecosystems in the world. We fueled the smartphone revolution and will power every technology revolution moving forward. We are defining the next universal mobile experience and redefining what's possible in IoT and automotive, in cloud computing and the metaverse. A 30-year history of trust and security and a legacy of energy and power efficiency brings hope for a sustainable future. We changed the world once. Now we have the chance to change it again. The future is built on ARM.
So now I remember why they had me start with a video, because it gets me excited. I really love that video, and I gotta say, thank you all for being here. It is fantastic to be back in Taiwan. I haven't been to Taiwan since before the pandemic. It was 2019. A lot has changed in the last 4 years. A lot has changed in the last 4 years. You know, what I love about that video is it highlights, you know, how ARM has really been pervasive and kind of all over our world every day. Many of you know ARM. I'm going to tell you a little bit more about it today, and I'm looking forward to that. You know, analysts say 70% of the world's population use ARM every single day. In fact, looking into the audience, I see some of you using it right now. You're on your mobile phones. But that's okay, keep going, it's good for business, so just keep that up. In all seriousness, you know, what ARM does is we deliver this leading IP across all sorts of compute platforms. You know, over our 30-year history, we've delivered over 250 billion chips alongside our partners. It's staggering. In the first 10 years, the partnership delivered about 1 billion chips. In the last 4 years, since 2019, collectively, we've delivered 100 billion chips. That just gives you a sense for how quickly things are scaling, how fast this is accelerating. And we're incredibly proud of it. You know, since 2019, the pandemic and digital transformation has really changed everything. They've brought chips and AI to the center of the conversation. Chips are cool. They weren't cool in 2019. But I figured out they were cool during the pandemic when my 12-year-old son, over dinner, started explaining to me supply chain logistics. He wanted a GPU for his new gaming PC and he couldn't get one. I thought that was the moment when I realized, when my 12-year-old was talking about it, that this was really starting to become something that everybody was paying attention. And of course now, over dinner, he talks about how his friends are cheating on their homework with ChatGPT. The point is, semiconductors are, you know, an incredible part of our everyday lives. In fact, earlier this week, we launched our TCS-23. TCS-23 is the platform for mobile computing. It's built around our fastest CPU ever, the Cortex X4, and our 5th generation GPU, Immortalis G720. This platform is all about enabling developers and the entire ecosystem to build the best visual experiences on ARM. And we've already partnered with folks like MediaTek and TSMC and ASUS to bring those experiences to life. Together, we're going to enable a platform that developers are going to be able to really move the bar on what it means to be a mobile experience. I encourage you guys to check it out. But you know, ARM's about a lot more than mobile. One of the areas where we've had a tremendous amount of traction is automotive. You know, we've been shipping into automotive for over 25 years alongside our partners. You know, and that's a big deal in an industry where supply chain security and stability are so important. Many of you may not know that 85% of IVI and cockpit systems are actually based on ARM. 50% of ADAS chips are based on ARM. You know, a big reason for our success here is because we took a look at the market and we deliver IP which is custom tailored to that market. We add things like functional safety to our processors, our GPUs, and our ISPs. But more important than that, we're actually driving automotive software ecosystem in an entirely new direction with initiatives like SOFI. Beyond that, we've had tremendous success in IoT. In fact, our market share in IoT is approaching 70%. It's fair to say that the IoT already runs on ARM. You know, IoT is this really interesting place within the ecosystem. It sits at the intersection of AI and those endpoints, IoT. Right at that intersection, you see computer vision. Computer vision is really taking off in a big way, and I want to highlight one particular partner that we have that's based here in Taiwan, and that's Himax. You know, Himax has long been known as a company which built these modules for laptops and PCs that could do identification. So you open your laptop, it knows who you are, and it allows you into the PC. But they wanted to do more. They wanted to leverage that experience they had to really create a platform so they could support all sorts of different use cases. And so we actually partnered with them using our MLIP, the Ethos family, using our MCUs, and leveraging our software ecosystem. They were able to launch a product back at Embedded World and turn themselves into a platform company so now others can develop and innovate on top of them. It's a great example of how they've transformed their business by leveraging ARM's technology. You know, in all three cases, there's this kind of common theme. Whether you're talking about TCS23 and the best visual experiences running on ARM, whether you're talking about automotive, or whether you're talking about IoT. In all three cases, ARM is doing the same thing. We are accelerating time to market for our partners, we're helping them reduce their investment, and we are enabling innovation. And that applies to infrastructure as well. You see, infrastructure is under tremendous pressure. In 2019, there were 0 5G subscribers. Today, there's over 1.5 billion. 1.5 billion, each of which has 10 times the bandwidth available to them. In 2019, there were about 5 billion IoT connections. Today, there's about 10 million more. The result of all that is about 4 times the data that is being generated every year. That's a tremendous amount of data, 120 zettabytes. And I'll save you all the Google search. A zettabyte is 1 billion terabytes. Just think about that. And on the other side, we have science and politics. Dr. Sun talked about Moore's Law. It might not be dying, maybe it's slowing. The point is, it's not what it used to be. It's creating tensions, this idea of continuing to just rely on the process nodes to give us 2x. It's not living up to that. And then you've got sustainability. You know, in some places, they're actually limiting housing development. Specifically in London, some boroughs are limiting housing development because of the power being used by the local data center. They can't support any more housing. Worldwide energy consumption for data centers between 1% and 3%, depending on the analyst you look at. And in places like Ireland and Denmark, it's even higher, 14%, 7%. Those are big numbers that we're talking about. And then we've got this thing that's happened which is this sort of shift to specialized processing, which is really a response to it. You see, CPUs of 2019, they were Swiss Army knives. State of the art was a 28-core device. That was it. You used it for everything. In the last 4 years, the ecosystem has flipped that on its head. In 2023, CPUs are specialized. You have cloud-native processors with over 100 cores. You have high memory bandwidth systems, which enable a lot more bandwidth on the device, whether that's to memory or to peripherals. You have edge devices, which have been optimized for power and have acceleration built in. So there's all this innovation that has happened over the last 4 years specifically to address that problem. But you know what? That innovation isn't free. It comes at a cost. And I think Dr. Sun, mentioned that as well. According to IBS, a 2-nanometer chip development on an advanced process node could cost as much as $700 million. $700 million. That includes all of the software, the IP, the verification. And it turns out, if you dig a little bit deeper, that those three things are actually the biggest chunk of the cost. Software, IP, and verification. That's where ARM comes in. You see, ARM Neoverse is the foundation for the future of computing in the infrastructure. It's the foundation for the future of the computing in the infrastructure because it's solving that problem. 3 simple reasons. First, technology leadership. Second, enabling the ecosystem the freedom to innovate. And third, and arguably most important, a unique dedication to a collaborative partnership with our ecosystem. That has been ARM's superpower since day one and continues to be so moving forward. Let's get into each of these in a little more detail and start with technology leadership. Back in 2018 and 2019, we launched our ARM Neoverse brand. Since then, we've had 6 new cores that we've announced. We're really broken up into 2 main product lines, our V-Series and our N-Series. Our V-Series cores are really all targeted to performance per thread. These are about scale up. They're really good for things like HPC and AI. They provide about 15% better performance than the latest generation from x86 on a per thread basis. And then we have our N-Series, which is really focused on scale out. These are great for things like web servers and networking. They sort of lead in performance per watt. Our partners, our cloud partners specifically, love the N-Series cores because they provide 45% better perf per watt over offerings from x86. This is why you're seeing such adoption in the market from a lot of these partners. The point that I'm trying to make is that the ecosystem, the infrastructure, is spread out into these 2 different types of devices. And what we've done is we've created CPUs which enable the ecosystem to go innovate and service both parts of the market. But everybody knows about our CPUs. That's a common thing that people think about and associate with ARM. What people might not realize is that we have technology leadership in a lot of other areas. And system IP is another fantastic example. Our CMM interconnect is second to none. It's unmatched in the industry. It's the key to scalable efficiency, letting partners scale from a very low core count to a very high core count, up to 256 cores. And it does so at an incredible cross-sectional bandwidth of nearly 4 terabytes per second. On top of that, CMM supports all the major peripheral and chip-to-chip standards. That includes things like Ampere, DDR5, UCIe, PCIe, CXL. But we're taking it a step further. We're showing technology leadership in systems as well, because we don't just provide IP. You see, partners more and more are looking to find ways to bring that big number down that it costs to build silicon. They want to innovate around compute subsystems, and so more and more, that's what we're delivering. We've brought together CPUs and interconnect and key system IP, and we integrate it, we configure it, and we validate it. And then we hand it to partners so they can take it right to physical design. This is all about saving partners time and valuable resources. And I got to tell you, it has been incredibly successful. We actually have partners we have multiple partners who have taken this already, and some even have silicon back. One customer had silicon back 13 months from project kickoff, with 100 cores booting Linux. 13 months. That 13 months, it includes cycle time in the fab. Another partner told us that it saved them 80 man-years worth of effort. Partners are leveraging the investment that we've made so they have a platform to innovate around it. The focus of their investment is innovation. That's how we solve the challenges and the pressure on infrastructure. Let's talk about innovation, because boy, are we seeing some of that innovation in action. You know, not having been here for 4 years, I've been talking to people all week. And one thing that has surprised people is how much innovation has happened on ARM in the last few years. If you look at all of the major firsts in the industry around infrastructure, they've actually happened on ARM. The first silicon to a terabyte per second memory bandwidth. The first to 100 cores. The first to DDR5 and PCIe Gen 5. The first to LPDDR5. The first DPUs, all on ARM. DPUs specifically are a huge deal. If you're not familiar with what's happening in the DPU market, it's fundamentally re-architecting the infrastructure. Okay? It's re-architecting the data center. It's all about disaggregation. We're disaggregating the compute functionality that's used to manage the infrastructure from the compute functionality that's required to run the application. This is driving a tremendous amount of efficiency within the infrastructure. You know, Facebook is famously quoted as saying as little as 18% of CPU cycles are spent on core applications, and the rest are just managing the infrastructure. This is about specifically going after that. And if you look at it, we've seen tremendous innovation from our entire ecosystem, whether that's AWS Nitro, Nvidia Mellanox Bluefield, Marvell Octeon, Intel Mount Evans, AMD Pensando. DPUs are being built on ARM. Another great example, and I won't dwell on this one too much because my buddy Jeff is in the audience and he's up next, is the work that's happened with Ampere. Ampere's done a tremendous job sort of paving the way for this idea of having a whole lot of cores per SoC. Their latest product, 192 cores. They now have a complete product family from 32 to 192 cores. And they're doing so in a tiny, tiny power budget. Again, I'm not going to get into too much detail because I want to let Jeff talk about it, and I'm sure he's going to. But this is some incredible innovation. And what we're seeing from the competition is they're really following us into that area, which is fantastic. And showing real leadership. And then there's this one. Some of you guys might have heard of this one this week. Right? Nvidia Grace. I had to bring up AI because you guys were starting to fall asleep. It's about halfway through the discussion, and I figured that would get everyone awake again. This one is showing off tremendous innovation as well. This family of products was really built and designed specifically to achieve unparalleled performance per watt. You know, we're seeing that in HPC and AI workloads specifically. It's either leveraging one, in the case of Grace Hopper, or two, Neoverse compute subsystems based on our standard, off-the-shelf Neoverse V2 core. This is incredible. It's got incredible memory capacity. It's got unmatched CPU to GPU bandwidth. And you know, you heard Jensen say, he held it up, right? And what did he say? This is a computer, it's not a chip. Well, if that's a computer, then the CPU at its heart is ARM Neoverse. It's fantastic to see this sort of innovation that we're enabling. And I love this particular use case, which he talked about as well, which was really about the partnership that we have with SoftBank and Nvidia to really reinvent what a 5G data center is. You know, SoftBank's building the world's first AI data center with Grace Hopper. They're talking about 4 times the ROI. But why this thing is so special is because it's solving problems in 2 different parts of the market, which people have been talking about. For those of you that aren't familiar, there's been this challenge with Open RAN over the years. Right? Are the economics going to work out? The telcos saw the benefits, but are the economics going to work out? So there's been that. And then there's been this other issue with the IoT and 5G in general, where there was this promise of being able to support all of these edge devices and to be able to do all of this compute on the edge to support all this data coming from the IoT devices. This announcement solves both of those problems. Because you can leverage and create multi-tenant environment, you can get 5G Open RAN for a much better ROI, because you can leverage that same hardware to do AI on the edge. And because you can do AI at the edge, right where that 5G happens, all of a sudden all those devices sending data in can actually do something useful with the data, which has been what's holding IoT back. That's innovation. And none of this would have been possible without our partnership. Our partnership with Nvidia, our partnership with SoftBank. You see, it takes an entire ecosystem to deliver this type of innovation. That's Arm's superpower. And it's why we work with all aspects of the stack, whether that's the silicon, whether that's the foundries, whether that's the ODMs. We engage at all different levels to make it happen. And we, of course, a big area of investment for us, a big area that we spend a tremendous amount of time is a software ecosystem. In fact, it's one thing that I get asked a lot. How is the software ecosystem doing for ARM? What about the software ecosystem? That box looks kind of skinny at the top. So I figured we'd do a slide on it. This is just a small set of the software that's now supported by ARM. This represents over 15 years worth of investment. The result of all that investment, all the major languages, all the major libraries, all the major tools, all the major OSs now support ARM as a first-class citizen. So there are 15 million developers that develop on ARM, for ARM. Millions and millions of developer hours specifically on ARM v9. And this is growing rapidly. For example, in 2019, last time I was in Taiwan, we announced that NVIDIA's CUDA would support ARM, and the approximately 600 AI and HPC applications that were supported on CUDA. This was in 2019. Today, that number is 3,000. That's the rate at which it's accelerating. That's a 5x increase. But it's not just increasing because of the investment that we're making, or partners like Nvidia are making. It's increasing rapidly because of the massive adoption that we're seeing with ARM across the board. Every major hyperscaler has now adopted ARM-based instances, and we're incredibly proud of that. Not only are they providing public instances based on ARM CPUs, but they're also adopting ARM-based DPUs to re-architect their infrastructure. And for them and their customers, it means a massive increase in cost savings. In fact, AWS has been quoted as saying that 48 of their top 50 customers are using their AWS ARM-based Graviton chips. The result of all that is an acceleration in the investment in the ARM ecosystem. That's our partnership with the ecosystem in action, and we're incredibly proud of it. You see, the future of the computing infrastructure is being built on ARM. And that's thanks to the technology, the leadership, and the innovation that we are enabling. But most importantly, it's because of our partnership with all of you, the broad ecosystem that makes up ARM. You see, ARM technology powered the smartphone revolution. That's a revolution that has undeniably changed all of our lives. We now have the opportunity to do so again. Together in partnership, we can transform infrastructure so that it's more performant, so that it's more efficient, so it's more sustainable. And we can do so while delivering on all those advances, all those promises that are being made by things like the age of AI and beyond. I'm looking forward to doing it together with all of you on ARM. Thank you.
Thank you, Mr. Awad, for your inspiring speech. Please return back to your